Hi, and welcome to our talk, Make MLOps Great Again. I'm Zoltan Todt. I'm a freelance instructor and solutions architect. Earlier, I worked for companies like Databricks and RapidMiner, and I used to run my own data consultancy, DataPow.
Hi, my name is Lajos Pap. I'm a freelance technical trainer and consultant. Previously, I worked for Hortonworks, and I also tried out myself in the startup area.
In this talk, we would like to show you a few tools and techniques which we coined the easy method with which we can make MLOps great again. So what does great MLOps mean? Well, first of all, it's an easy developer experience. Of course, when you start working with an MLOps system and you start implementing an MLOps system, then you want to have something enterprise grade, but actually you will need to get there eventually. And you, especially if you're a data scientist, you don't care about Docker or Kubernetes or CI/CD pipelines or all of these things. So you want to make sure that when you work with MLOps, then you have a smooth sailing and not a super steep learning curve, because this will enable you to actually get into it. Another important piece is the works the same way on my machine as on yours. So you want to make sure that the code and your models and the whole prediction and serving logic, it works exactly the same on your machine without Docker, on a local machine with Docker, and on a full-fledged multi-node Kubernetes cluster. And third, we want to make sure that this handoff of responsibilities between a data scientist and a data engineer and DevOps is as simple as possible. So in this talk, I will talk about a data scientist perspective and what I, as a data scientist, want to do and what's important for me. And then I will just hand it off to Lajos, who will take a data engineer and DevOps perspective.
Okay, so I will play the data engineer or DevOps role. So basically, at the beginning, I will just sit here silently and wait until the data scientist finishes his job on his laptop. And then I will take it over and put it into a real production 6-node Kubernetes cluster.
So here what you see is the MLOps lifecycle. I'm quite sure that many of you have already seen this figure. And basically what you want to see here is that there are different roles in this lifecycle. There is the data scientist and data analyst who design and then develop the models. And then there is a more engineering and DevOps-like role, which is the operations role. And usually what we see when we work with companies is that there is quite a large barrier between the data scientist role and the operations role. Especially if you're a data scientist and you somehow want to try out your model, or you want to try to work end-to-end, that can be very, very complicated, because deployment and research and model building, they require different competencies. So here the problems we see is that many data scientists, especially talented data scientists, they want to work end-to-end, but they don't care about Docker or CI/CD or Kubernetes and so on. But if they wanted to choose a set of tools that can help them to take the model to production or close to production, just to get started with a project, the MLOps landscape turns out to be super complicated. So for example, if you just take a look at this figure, which was published by Neptune AI, one of the MLOps managed services out there, you can already see that even with just a glimpse of the tooling that's available, it's vast. So how can you find the best tooling and best techniques to achieve end-to-end competency of building and deploying your models? Now, what we see is that when you are looking for a tool, then there are some general considerations that you want to go after. One is that when it comes to model serving, then you want to make sure that you are able to test your model serving exactly using the same environment, using the same exact environment locally as you will see in production. So we can avoid this, it worked on my computer trap, right? Also, you want to make sure that the solution that you choose scales and it is highly available if you want, and it integrates well with CI/CD, right? So you can automate as much as possible of the workflow. And then if you take your model and your model development seriously, I'm quite sure that there are some compliance requirements that you want to take into account. For example, it can happen that due to regulations, you will need to be able to tell for every prediction in the past why you made this prediction and with which model. So just think about, let's say, the insurance business. So you will need to make sure why someone's score in an insurance case is high or low. You need to make sure that that's something that you can explain later, like years later in court, for example. And also there is security. So you want to make sure that your models can be only accessed by those who are eligible because they might store sensitive data. And you also want to make sure that the whole model supply chain is secure. So you have a secure way of building and deploying your models and a verifiable way. So you can make sure that the model that you run is actually the model that your data engineers or data scientists build. So this was kind of a general requirement, but then if you're looking for a tool, you also have some quite specific requirements. Now going down to details. So I'm quite sure you want to look for something that supports the Python SDK, because many of these models are built with Python. You can consider working with a managed solution or using a proprietary or open source solution. We are pro open source because that goes without a vendor lock-in. And also many open source solutions have hosted versions. And we also want to make sure that the solution that we build and use is extensible. You also want to make sure that the solution, the tool you pick, it gives the tools for data scientists like experiment tracking or model registry, and of course, model serving. And another thing, you want to make sure that the whole thing is cloud native, so it works with containers. So these are some of the functional requirements from a technical point of view. And then there are two requirements that we take quite seriously because of our project experience. And one is the developer experience. So the tool should be easy to start with. Probably if you are Google or Spotify, then you have a very well set and sophisticated tooling. But as someone who gets started with MLOps, this is not what you need. You need something that you can get on speed with super easily, and then you can scale it out and make it enterprise grade later. So developer experience is something that we care a lot about. And we care a lot about the data scientist and the data engineer / DevOps handoff experience. So it shouldn't be too much of a hassle to take the model to production. So we took a look at the landscape as we worked with MLOps tools and different solutions. And we would just like to highlight a few of them. So we picked a few, like Neptune AI, which is a managed solution, KubeFlow, which is one of the larger standard MLOps solutions. It's like a quite robust project. Also, AWS SageMaker, which is Amazon's ML solution. It's like a umbrella term for all of MLOps and ML in AWS, and MLflow, which is a Python-based MLOps solution, mostly developed by Databricks. So if you take a look at the functionalities, then you will see that the Python SDK is supported by all of them, as with basically every MLOps project. In this case, because we looked for an end-to-end solution, experiment tracking So the data science toolkit is there. So this is great. But then you will see that things get a little bit more sophisticated when we care about, for example, a unified model packaging. So to have a model package format that can host, let's say, an XGBoost model, but also a linear regression model or a deep learning model. So with Neptune AI, you can kind of do it. And with the rest, this is okay. We wanted to see an open source solution and use an open source solution. So at the end of the day, we didn't care too much about Neptune AI and SageMaker because they will have the risk of lock-in. And then again, the developer experience, too easy to get started with, is actually with the managed solutions. Of course, it's trivial. And then when we work with MLflow and KubeFlow, there is a huge difference. So with KubeFlow, even though it's like super feature rich, you basically need a Kubernetes expert and a day of work of a Kubernetes expert to have something proper up and running. Whereas with MLflow, yeah, that's right. and whereas with MLflow, it's quite simple. It's basically a pip package, and it works very well. So we also took a look at cloud native serving, so serving through Docker containers. Neptune AI is not a platform created for serving. KubeFlow and SageMaker, they do this well. And MLflow, it does it to some level. So you can compile Docker containers for MLflow, but the serving capabilities of MLflow is kind of limited, especially when you want to have some custom serving, custom endpoints, or some extra logic in your serving component. We also took a look at some of the others, but as they weren't end-to-end solutions like TensorBoard and Bend2ML, or they weren't general enough, we didn't include them. Okay, so let's take a look at a closer look at MLflow. So what MLflow does for you is it provides an experiment tracking and model registry component that data scientists can use. It provides a model packaging format. It's called model flavor, so a unified model packaging format, and also model serving with Docker. So it looks great, but actually then when you go and try to work with the open source MLflow, and I say open source because MLflow is an open source project, but Databricks is the main contributor of MLflow, and there is also a proprietary offering of MLflow on Databricks. Then you will see that the open source project goes into a few limitations, like tracking and registry security. It's basically non-existent, or you can have some basic authentication, and that's all. Model serving security, non-existent. Model serving, as I told you, is very, very limited. It gives you just a standard endpoint with some model support, but you cannot really customize it too much. Also, the registry is set up in a way that it works well in a managed proprietary environment, but it's I wouldn't say it's useless, but it is a very limited use, I would say, in the open source setting. And if you want to have a reproducible serving, so you want to take the code with you and the data or anything like that, then that's also quite limited. Well, now here the thing is that as Databricks is the main contributor, it comes at no surprise that these things are implemented quite well in Databricks. But we wanted to, take a look and just see, hey, can we just somehow make this better? Because if you just take a look at a deeper look at what serving is, once you have a model, then you will realize that the core serving component is super, super simple. So what you see, for example, now on our screen is a fast API-based machine learning serving REST API, which is, as you can see, not even 30 lines of Python code. And it works quite well. So serving might be able to make cloud native in an easy way.
Okay, so how can we make our model cloud native? And first, let's define what cloud native is. Actually, there is no real definition of cloud native, so I will just give my sort of thinking about what cloud native means. It means that you are able to put your whole software stack into containers. Why it is important? For two reasons. One, this can be a packaging format, so you don't have to package your application differently for different Linux environments, differently for different operating system. You will have one single packaging format, and it will make sure that you can move your whole software stack in the same way without touching it. Okay, so the next one is, you can see it on the point that we would like to use Kubernetes ingress for robust serving. What does it mean? You don't really have to know all the details about what is a Kubernetes ingress. You can think about it is like, it is the single entry point for a Kubernetes. So all the HTTP incoming requests for the production system is going through on the ingress controller. You can think about it like a reverse proxy. So it's Nginx AJ proxy, or the usual reverse proxy stuff. Now what we can do here in one single point, we can implement here additional features. What are the additional features? Okay, what happens if you would like to provide, for example, authentication? At the very least, you need, let's say, basic authentication. Okay, and then later you might want to add a HTTPS endpoint, or later you want to set some course headers, which is like cross-origin working to make sure that the web API is working with the backend API. All this stuff could be implemented inside of your software stack, but that means if you want to add enterprise features, you always have to change your code. Now you can completely avoid it by putting all these extra features into the infrastructure layer. So what we can achieve is that we can put all these extra features like HTTPS endpointing, authentication, all this stuff into the infrastructure layer. So at the end of the demo, what you will see that first we will have a very simple basic working web interface, and then we will be able to add easily authentication on top of it without even changing anything in the Docker image. And the last point is that our basic idea is that there are different ways to move your model. You can think about it like, okay, my model is up on Hugging Face. I can download it there. Or there are different storage options like S3 and so on. And our idea was like, if we already putting everything into containers, then why don't we push our model also into a Docker image? Because this will give us all the possibilities what the container image registries gave us. So for example, you can sign your images, which means you are signing your models, and you can also make sure that there is no way that a man in the middle can change the model while you are moving it from your laptop to the production system. So everything is more secure. Okay, so these are the points. What we can reach is registry secure, tick, because we put it into a container registry. It will be reproducible. Now it's a side note that Docker images can be made reproducible bit by bit. It's not out of the box, but there are solutions to do that. You can verify that it's really you who is creating this model. And we can also add model serving security with ingress. Highly available is as an absolute given with Kubernetes, and scalability is that's again one feature of Kubernetes which is easily achievable. Okay, so let's start the demo. Now back to Zoltán.
Thanks, Lajos. So the demo code and everything that we show you here, the whole infrastructure is available as an open source package and repository here on GitHub. So under Easy ML Dev, you will find packages and repositories to work with. Just go and open a code space for this repository. And here we are. And again, I am a data scientist. So what I want to do once I'm done with my model research is to create a program that trains my model, and that's something that I can put into the model training pipeline. So here is a train model file that I created earlier. You can see that it's kind of simple. You can take a look later in the repo. It is a spam classifier. So it receives a message, for example, a comment or a Slack message or something like this, and it will try to classify if it's spam or not. So I have some data science code here. And at this point, I'm already done with the data science piece. So let's just make a model out of it. So what does a model need? It needs an environment. So I can define the PIP requirements. So this is a scikit-learn-based model, and we use MLflow. So MLflow is there as a requirement. It also needs some metadata. So we can construct the input schema and the output schema, and also just give a few example data. So for example, click this link and subscribe to my channel. Let's assume this is YouTube, or this is the best ever video about MLflow. So you can easily guess that this would be spam and this shouldn't be spam. And then I can go and using the MLflow API, save this model along with the environment, so the requirements and all the metadata. So let me execute this code. So I will just say Python train model.py. All right, so my model is now saved into a folder. So now that I have my model, what do I want to do? But first of all, probably I want to do some local testing. So I created a test for this model, which is here, test model.py. So this test model, it just loads my model and then makes a few predictions and checks if, for example, subscribe to my channel is spam and this video is great, whether it's spam or not. And also I can take a look at the accuracy of the model as I saved it as a metadata and just make sure that I'm not deploying a model that has a lower accuracy than my accuracy baseline. So this can also be done in our infrastructure simply by saying pytest. And then these two tests are executed on the model, and you can see that this passed. All right. So we are ready to go with Dockerizing and testing our model. You can simply say make run volume, and this run volume means that the infrastructure that we have here, it will take our model and, just as Leo said, it will package it into a very lightweight container. So the model, only the model and its dependencies itself. So now I have a Docker service up and running. If I take a look at the images, you will see right away that I have something called the serving API, which is my serving API, kind of the base image, that's a larger one. So that's something you need to build one time. And then you have your model here with its dependencies. And you see that it's kind of small, especially if you usually work with models, a deployment can be gigabytes. But this case, by just injecting a model on top of a serving API Docker container, you can keep the model code very, very small. And this is really what you need to deploy and version control and so on. So the whole thing is quite small. And now it's running already in a Docker container. And I can test this now with a simple curl command by pinging this endpoint and just passing a subscribe my channel message. Here we go. All right, great. So this is classified as spam. So the whole thing works. So I will just go and submit this to Git. So let's take a look at our tags. I'm at 1.2.2. So I will just say git tag, this is version 1.2.3, and let me just push this. Okay, so now I just push my pipeline, right? And now if I go to the workflow, then you will see that we have a GitHub action running here automatically. Again, this GitHub action code is in our GitHub repo. So the whole logic of taking a new model, building a lightweight container, and packaging it together with the serving and also separately, and all the heavy lifting is done for you.
Zoltan, as a data scientist, shouldn't know anything about CI/CD. I was providing all this environment beforehand. So all my instruction was to Zoltan that once you're ready with your image, tag it, tag the Git repository, and push it to the GitHub repository. And rest assured, the images will be built. All right, okay, so now it's again turn for the data engineer or the DevOps engineer to do the rest. So look, now you can see it on my screen, the text file, which is a YAML, which drives the CI/CD pipeline. So actually a very easy way to have a free CI/CD if you are using GitHub Actions. And look at this, in this GitHub action, actually, I'm using the pre-built GitHub action, and all I had to do is give the name of the Docker image we want to build and distribute. So we are using also, again, it's a free image registry provided by GitHub. That's the name, GitHub Container Registry. This is our organization, and you can see that the name of the image will be easy serving spam. Now, it's also important that when we are building the image, we also put a tag on it, and we are using a semantic versioning. So with v1.2.3 or something similar, but we're also putting some other tags as well. So for example, you can always refer to the Docker image by the git short tag. Okay, so now I'm going to the terminal, and now I can check whether the image is already built and pushed. I'm using Crane, which is a GitHub Container Registry query tool, and all the tags will be sorted by version semantic. So look at this one. Okay, so now you can see that the latest version is already up and running. Now, if you are working with Kubernetes, you know that usually you are creating a Helm chart for your whole application. This is the case in our application as well. And I can show you that the previous version was built with this very simple Helm chart. And actually the Helm chart values what you can see it on my screen. So you can see that the last time when I was building, the latest version was 1.2.2. And now because the latest image is ready, all I have to do is change this one to 1.2.3. Okay, so now I've changed the file. I go back to the terminal. And just to prove you that it's nothing on production yet, I'm just showing you what are the releases, and you can see there are no releases. So now all I have to do is, first I have to create a Helm release for the backend service. Okay, so first let's prove that it's not running in the production. So I'm going to the web browser, and you can see that the web.easyml.dev site is just not working right now. Okay, so all I have to do is just create an upgrade. And first, look, I explain all the parameters. So Helm upgrade-i means upgrade the release code spam, or if it's missing, install it. This is the chart we are using. And the values, I'm just pointing to the production values. Okay, so let's do this. Release is not existing yet, so it is creating it. And now if I'm doing a kubectl get pods, I can see that it started in 8 seconds ago. So far, so good. Now we have to do the same for the front end. Okay, so this is the command. It's very similar to the previous one. I'm creating a new release called web. I'm using a different charts, and the values is coming from the web values YAML. Okay, let's just do that one. Okay, it's also created. Let's check the pods if they are running. Okay, 5 seconds ago it's created. And sure, look, it's up and running. So this is a very simple HTML served by the serving front end. And all it does is when you write something here in the box and you click check, then it will talk to the backend, which will call the model, and we can see that we get back a 0, which means that this type of text is not a spam. And I can check if I say something like that was easy, but subscribe to my channel. And if I click a check on it, now we can see that the response is 1, which means it's a spam. Okay, so now the next thing is, which I would like to show is that, look, there is no authentication on the front end. Now, if you would like to do and implement it in Python, then yes, you go to the FAST API website, you read how to add basic authentication, you create the code, you test it, you build a new image, you have to push it, and so it's really long. There is a better way to do it, because that's where Kubernetes really shines. And now all I have to do is just add 3 annotation. Look, this is it. This is all what we need. We tell the Nginx ingress controller that we want to have basic authentication. The last one is just the error message if we are failing to provide the username and the password. And the second one is pointing to a secret which holds the username and the password. Now I save the file. And if I go back to the terminal, all I have to do is just create a new revision of my HELM release. Look, it's happening quite quickly. Now, this is the latest one. And if I go back to the UI, and if I try to do a refresh, oh, look at this one. Basic authentication is already implemented. Let's use username foo and the very secret password, which is 3 letters. No. What the other 3 letters? And look, I can reach again the UI. And even I can show it from the command line. If you try to reach it, you get a 401. So basic authentication is needed. Now the very last step that we can show that it's really in production. What I did, I was integrating this spam service also into our own chat program. So for that reason, we will use Mattermost. It's really easy to implement because you just have to create one Docker container and we have our own chat. So now I can start to chat with Zoltan. Hey, Zoltan, what's up? Okay, and meanwhile, I can show you that if we start to show you some kubectl logs, kubectl get pods, and this is the bot. So the bot is running also in this namespace. So if I do a kubectl logs, deployments per bot, look, the bot is intercepting all the messages, what we are writing, and checking whether it's spam or not. So look, here I was saying, hi Zoltan, what's up? And the bot was calling the spam API and the response was 0, so it's no spam. Then Zoltan was responding with hi. Again, calling the spam backend service responded with 0. So now, Zoltan, let's write something which might be spam. Oh, and look at this one. The bot detected just some spam. So look how easy it was.
So thank you very much for attending our talk. And check us out at easyml.dev, or if you have any feedback, just feel free to reach out to us on LinkedIn.